degrees. We know that we have a right triangle, so we can use our SOH CAH TOA. And let's look at what sides we have. We're looking for the side that is adjacent to the 39 degrees, and we were given the side length that is opposite. So we're missing one of the legs and we're missing the hypotenuse. For that reason, we cannot use the Pythagorean theorem. So we know that we can use trigonometry. Okay, which trig function allows us to put a ratio between our opposite side and our adjacent side? So CAH TOA, so TOA, tangent of opposite over adjacent. So I'm going to write the tangent of 39 is equal to 30 over x. Okay, and you might be wondering, well, what does tan 39 mean? In your calculator, you have to make sure that you are in degree modes. So if you hit mode in most TI calculators, you're going to get a menu that looks something like this. And you see that there's an option for radian and degree. You want to make sure that you're measuring in degrees. Okay, so now here are my three trigonometric functions: sine, cosine, and tangent. So if you type tangent of 39 degrees, you get this value 0.809784, and on and on. We always take the first four values after the decimal place. So we're going to go to 4 decimal places. So 0.80978, since it's 8, this has to turn into an 8. So 0.8098 is what we would be interested in multiplying here. Not multiplying, so replacing the tangent 39. Okay, so since we have a proportion, tangent 39 has a denominator of 1, we can cross multiply. So x times tangent 39 is equal to 30 times 1, which is just 30. Okay, and now to solve for x, we need to divide by tangent of 39. So 30 over 0.8098 is 37.05 centimeters. And that is how you find a missing side length using trig functions. Okay, let's try another example. Okay, in this exercise, we need to solve for this triangle, and we're going to list the properties or theorems that we used. Okay, so we have a triangle ABC that is a right triangle with angle A measuring 30 degrees, side AB measuring 12 square root of 3. Okay, so let's start out by solving for the missing angle. So the measurement of angle C plus 30 degrees plus 90 degrees is equal to 180 degrees. So angle C is 60 degrees by the triangle sum theorem that we use to find a missing angle. Now, we are missing side BC and side AC. Since this is my 30-degree angle, AC is my hypotenuse because it's directly across from the 90-degree angle, and BC is opposite from 30 degrees. So to find BC, we're going to start out with tangent because we have the adjacent and we're missing the opposite side. So tangent of 30 degrees is equal to BC over 12 square root 3. We're going to cross multiply, or we can multiply both sides by 12 square root of 3. Both are valid ways to solve for BC. Okay, when we multiply both sides by 12 square root of 3, on the right-hand side, these two will cancel out, leaving us with BC is equal to 12 square root of 3 tangent of 30 degrees. Okay, if I type tangent of 30 degrees here, I get 0.57735, so I'm going to round up to 0.5774. Okay, so 12 square root of 3 times 0.5774 ends up being 12. All right, so now let's find our missing side AC. Okay, so are we going to use the sine of angle 30, the cosine, or the tangent? Well, we need something that deals with hypotenuse because AC is the hypotenuse. That means SOH CAH. Well, if I want to use 12, because I don't want to end up using the more complex number of 12 square root 3, that means I have my opposite side and I am missing the hypotenuse. So I'm going to use SOH. So the sine of 30 degrees is equal to 12 over AC. I'm going to cross multiply and then divide so that AC is equal to 12 over the sine of 30 degrees. And that means that AC is equal to 24. Okay. And the way I would do this in the calculator is, let me clear that out. I would type in 12 sine 30 degrees. And I'm going to close the parentheses. It helps if I divide 12 divided by sine of 30 degrees. Okay, that is equal to 24. And that makes sense because AC is my longest side. If I had gotten 6 for the answer, then you know you have to go back and find your mistake. Okay, so AC is 24 units, and we said that our missing angle, angle C, was 60 degrees. Okay, so we used trigonometry to find the missing sides, and we used triangle sum theorem to find the missing angle. Okay, let's try one more. Okay, in this case, we have an angle that's 45 degrees. And we were given a hypotenuse, and I can recognize the hypotenuse because it's directly across from angle A that is 90 degrees. And once again, we're dealing with a square root in the number. Okay, so since we have the hypotenuse, I know that I'm going to be dealing with either sine or cosine to find the missing side lengths. So let's start out with cosine of 45 degrees. And cosine of 45 is equal to my adjacent side, side AC, over 6 square root 2. That is my hypotenuse. Okay, and when we cross multiply, AC is equal to 6 square root 2 times cosine 45. And if I type into my calculator cosine of 45, I get 0.70710. So since I want 4 decimal places, I stop at the 1. So 6 square root 2 times 0.7071 is equal to 6. Okay, if you do it all in the calculator at once, you can type in 6 square root 2. Nope, 6 square root 2, and I want to get out of the square root sign, times cosine 45 degrees. Okay, and that gives me a value of 6. Okay, so let's type in here 6 for that value. Okay, now let's look for AB. We're going to use the sine of 45 degrees, and that would be AB, not AC. Let me fix that. Okay, so sine of 45 degrees is equal to AB over 6 square root 2. Okay, so AB is opposite my reference angle, and I'm going to cross multiply. So I have 6 square root 2 times sine of 45. So what is sine of 45 equal to? Oh, look, it's the same. Cosine 45 and sine 45 are actually the same. That makes this a very special triangle. And if you haven't figured out what type of triangle this is, we will soon find out. Okay, so 6 square root 2 times 0.7071 is, again, equal to 6. Oh, interesting. Why would that be 6? Well, if this is 45 degrees and this is 90 degrees, then what would angle B be equal to? It would be 45 degrees. So triangle sum theorem tells me that if this is 45, angle B is also 45 degrees. And we used trigonometry to find the side lengths. So we know that this is an isosceles right triangle. So it makes sense that the legs would be equal. Okay, and if you want to learn more about an isosceles right triangle and how to use trigonometry, notice that this value here also matches the legs. There's a special shortcut for the 45, 45, 90 triangle, as well as the 30, 60, 90 triangle. And I encourage you to figure out more about these two special triangles because they come very handy. Okay, notice the 12, square root 3. One of the legs is 12, and the hypotenuse is just twice as much. Okay, so I encourage you to find more information about the 30, 60, 90 and 45, 45, 90 triangle. Okay, now you try this.